Hello and welcome to R&D Mathematics. In this video, we are going to talk about quadratic formula, the theory part. In last video, we learned quadratic formula, but in this video, last video we learned how to use it. So this is your quadratic equation, and then x is negative b plus or minus b squared minus 4ac divided by 2a. And also, when we are learning that, there is something known as discriminant. We are going to talk about that. Actually, that is the part. Let me write. A discriminant is actually nothing but we denote it by delta b squared minus 4ac. Now, this is a special value. Just by looking at this value, we can distinguish a quadratic equation. See, this value is exactly that expression appears inside the radical sign. Now, let's see why this happens. In order to do that, you need to recall when we are learning factoring equation, we learn something known as completing square. You must remember that. Now, let me show you how this comes. Ax squared plus bx plus c. If I pull a out, x squared plus b over a x. See, when I multiply a with b over a, I get b, right? Plus, similarly, c over a equals 0. Now, see, what I did was I make in this part of the equation, this is 1 here. That's exactly what I did by pulling a out. So I just have to keep a out and deal with the other part. Now, completing square technique. Remember, let me take an example. Let me take a simple example and recall you. So let's say x squared plus 6x plus 10 equals 0. This is not a perfect square, by completing square, you take these two terms. So x plus, you take this guy and divide it by 2. 3, then squared. Now in your mind or in a separate place, you check what this is. So that's x squared plus 6x plus 9, right? That's coming from a plus b squared equal a squared plus 2ab plus b squared, that formula. Now what we have here is 10. So this part is already in x squared plus 6x plus 9, but I need x squared plus 6x plus 10, so I need one more. This technique is known as completing a square, and it is related to this formula. Now using that technique, now let me erase because I need room. What we are going to do here, this part. So my coefficient is this, so divided by 2, I get x plus b over 2a squared. So exactly like this, what I did over here, now I have to do in my mind or in a separate place. I have to expand this. So x squared plus 2 times x times this term, which is b over ax. So actually, okay, let me take you back to this example. See, when you divide this number by 2 and then you get 3 here, x plus 3 squared, automatically this part, the first two term is, you are getting first two terms. What you need to do, adjust the last term as needed. So this part is same as this part over here, and this square part will give me a third term, like here 9, which is going to be b squared over 2a squared, which is 4a squared. And I only have here c over a. In order to balance that, I have to have minus b squared over 4a squared. equals 0. Now this proof part is little bit tricky. It can be a little bit tricky for some of you in this college algebra class. So if you know in your exams and things like that, you will not be tested on the proof part, but it's interesting. In mathematics, it's always good to know why these things are coming, why and where and how these things are coming. Then you will understand it much clearer. Now I need parenthesis here, a times, so x plus b over 2a squared plus, here I'm going to, in these two terms, I'm going to take common denominator 4a squared. Then I need to multiply first by 4a, so 4ac minus b squared equals 0. We know a is not 0, right? We know a is not 0. It can be 0 in the quadratic equation. That forces this part to be 0. So what we are getting here is x plus b over 2a squared equals, when I take this whole term to the other side, sign changes, b squared over 4a squared, right? Now I need room, so let me do it over here. Now square root technique, my x plus, let me choose a different color, x plus b over a is going to be, see here, x plus b over a squared, square root of the whole term in right hand side, right, for a squared. If you observe for a squared, if you observe closely, see it's already started to appearing. So x plus b over 2a, sorry, here plus or minus, top part b squared over 4ac, bottom part 4a squared square root, which is 2a. Now it's a matter of taking this term to right hand side, negative b over 2a plus or minus b squared over 4ac over 2a. Now we have the common denominator 2a, so negative b plus or minus b squared over 4ac. See, we have proved it. And now this part, we call it the discriminant, b squared over 4ac. Without the square root part, what appears in the denominator? Now let's go to the next page. Okay, discriminant b squared over 4ac. Now if the discriminant is positive, now this is the theory behind discriminant, we will have two roots. If it is 0, we will have one root. If it is less than 0, we have no root, or in this case, complex numbers will appear, complex roots. Now let's see why. Using an example. Let's see an example. X squared plus x minus 2 equals 0. Now a is 1, b is 1, c is negative 2. If you take the discriminant, b squared minus 4ac, 1 minus 4 times 1 times negative 2, which is 1 plus 8, which is 9. See, at this step, you don't even to simplify for the last one. If you can, at this step, if you can identify that's positive, that's it. You have two roots. And actually, let's go ahead and solve this. It has factors. This is easy. X, and I need 2, so 1 and 2. I need positive 1 in the middle, so 1 here. See, 1 is going to be 1, the other root is going to be negative 2, and 2 distinct real roots, so it's 2 distinct. I forgot that. Now let's take another example. How about this? x squared plus 2x plus 1 equals 0. Now in this case, a is 1, b is 2, c is negative 1. So c is 1, positive 1. C is 1. So discriminant b squared minus 4 is c, b squared, so 2 squared minus 4 times 1 times 1. 2 squared, which is 4, minus 4 into 1 into 1, 4, it is 0. So in this case, according to our theory, only one root. Now let's actually solve this. Solving is pretty easy because if you observe, this is actually x plus 1 squared equals 0. So x is plus so minus 1, right? No, sorry, x is actually negative 1. Because in this one, what you have here is x plus 1 into x plus 1 equals 0. So both of them are the same root. So one root is repeated. See, that's why when the discriminant is 0, you only have one root, and in this case, we have a repeated root. Now, let's take another example. How about this? X squared plus x plus 2 equals 0. Now, in this case, A is 1, B is 1, C is 2. So discriminant b squared minus 4ac. So 1 squared minus 4 into 1 into 2, which is negative. You don't even have to simplify, but so negative 7, which is negative. No solutions according to our theory. Now let's investigate a little bit. Let's start with the first example. Now, well, what I'm about to do is actually in future when we learn quadratic functions, but it fits nicely here. Let me explain you why all this story is happening. Roughly, briefly, let me explain. In a future video, you will understand when we learn quadratic functions, what's happening here. See, y equal x squared or fx equal x squared quadratic function looks like this. Now, any quadratic function, this part, if you put it y equals this part or fx equal this part, that will have the same shape, and it will do shifting, like it will shift right or left, or it will flip up and down, and it will either stretch, shrink, according to these numbers that appears according to the coefficient. So what's going to happen, basically what I'm telling here is, when we learn transformation of functions and quadratic function, we learn this in detail, but any quadratic function will look like, without drawing the axis, will either look like this or this. It can be fat, it can be thin, according to the numbers, but it will look like that. Now, let me erase this again. When this happens, let me draw the axis now, x-axis and y-axis. Y-axis will always be crossed exactly once. Now, if you have quadratic equation like, graph like this, how many places it crossed x-axis? 2. Now, see this equation, something like this, when you say equals 0, y equals x squared plus x minus 2. And this equation is when y equals 0 of this equation. So it represents right here. So you have two solutions. Sometimes it may be the case your turning happens like this. Right here. One solution, one root. Sometimes your turning happens like this. It does not cross in that way, no root, or like this. So that is the idea behind that. But again, let me see, where did I? Yeah. In the quadratic formula, see when this part, now let me explain this. Guys, this is a theory part, but this is nice. This is really nice. So x equals negative b plus or minus b squared minus 4ac over 2a. Now look at this. If delta is this, so you can actually write down your equation like this, delta over 2a. So if delta was positive, see for example you are getting something like this plus or minus, that's positive because of that it exists, and you can break it into two parts like this, right? See a minus. That's why when it is positive you have two roots. And if it is zero, this whole thing is zero, what will happen is it's just this, because plus or minus zero is just zero. One solution. And if it is negative inside like 14, now this is complex, not no longer two complex roots. I think that's clear, right? And that's enough actually, that's enough for the time being. We must talk about this again when we do quadratic functions. Okay guys, thank you.